everybody, Ms. Daly here, and this week's lesson is about the probability of compound events. So that is the probability of multiple things happening consecutively. So in our first example, we have a map. And it says, if you randomly choose paths along the map, starting at point A, what is the probability that you end up at point I? So here's our map, and we're going to construct an area model to help us figure out the probability of ending up at point A. So every single time that there is a choice to be made in the map, we are going to cut up our area model, which just starts as a square, to represent those choices. So the first choice that we have on our map is starting from point A. And from point A, we can either head up towards B or down towards C. I will also cut it so that there's a top path. This would be along, you're headed in the direction of B, and this one, you're headed in the direction of point C. Now, if I went to point B, I would then have 3 different options coming out of point B. So I'm also going to take this path here and cut it into 3 equal size sections. One of those ends up at G, one ends up at I, but the middle one splits again into 3 options, going to either G, H, or I. Our first one went to G, the bottom one went to I, and the middle path split into 3. One went to G, one went to H, one went to I. If way back here I had gone this path, I would have ended up at C. C then splits into 2, and each of those splits into 2. So I'm going to show that in our area model. So path C broke into 2, and each of those broke into 2. The path that went to E then broke into I and J. The path that went through F broke into J and K. So I, J, J, K. So the question being asked was, what was the probability that you end up at point I? Well, there was several ways to get to point I. I could have gotten there this way. I could have gotten there this way. Or I could have gotten there this way. So I need to find the size of all of those pieces and then add them together. So we had cut it in half and then cut that into 3 equal pieces. So that means this one is 1/6. This piece was a 1/6 that was broken into 3. So that means this is 1/18. And this was a half that we broke into another half. So that is a 1/4, and we broke that into a half, which means this one is 1/8. For the total probability of ending up at point I, we take 1/6, add 1/18, and then 1/8. 1/6 is the same as 3/18. So when I add those two together, that would give me 4/18 or 2/9. And then I still have to add in my 1/8. The common denominator for those is 72. 2/9 is the same as 16 72nds, and 1/8 is the same as 9 72nds. So altogether, that means that our probability of ending up at point I is 25 out of 72. To change that into a percent, we divide the numerator by the denominator and multiply by 100. Which gives us approximately 35% of a chance. For our second example, we're going to start with a situation that happens in a basketball game, which is that when you are fouled, you get to shoot from the free throw line. So in this scenario, when given 2 free throws, Joe makes 25% of their first shot, and they make 40% of their second shot. So, what is the probability that Joe will make at least 1 point in a 2 free throw foul situation? So we start with our area model again. Along the top, we will reflect what could happen on Joe's first shot. So on their first shot, it said that they have a 25% chance of making it. So 25% as a decimal is 0.25, so this is the chance that they will make their first shot. And that means that there is a 75% chance that they will miss their first shot. And then we split our area model into those 2 outcomes. For the second shot, they get a little more confident, and so there is a 40% chance, or 0.40, that they will make their second shot, and that means that there is a 60% chance that they will miss their second shot. To find the size of each of these individual outcomes, we can just multiply the length and the width, because it's really just the area of a rectangle. 0.40 times 0.25 equals 0.1. And that's that they made both of their shots. So that's the chance that they will make 2 points at the free throw line. 0.40 times 0.75 makes 0.3. And this is that they miss their first shot, make their second shot. So in this scenario, they would get 1 point. 0.60 times 0.25 is 0.15. This is that they make their first shot, but they miss their second shot. So again, this is also 1 point overall. The last is that they would miss both shots. So 0.60 times 0.75 is 0.45. And that is when they make 0 points. So if we are looking for the probability that they will make at least 1 point, that would be all 3 of these sections of our area model. So we would add those all together. 0.1 plus 0.3 plus 0.15. That would make 0.4 and 0.55. So the probability that they make greater than or equal to 1 point would be 0.55, which is the same as 55%. Good luck, everybody, and I hope to see you during our Google Hangout. Bye.